Hello and welcome to eMind's Technology again. This is part 1 of BGP continuation. It's continuation of part 1. I can say part 1 of 3. In part 1 I have 3 parts, 3 subparts. This is the third subpart, the final part of part 1. Now in the previous video what we were discussing is about IBGP in a transit autonomous path. What is transit autonomous system? If an autonomous system is in the middle used by different autonomous systems, meaning A is in one autonomous system, F is in autonomous system 3. In order to go from A to 3, 1 to 3 or A to F, you use autonomous system 2. That is, you go via someone else autonomous system. Neither source is there in that middle autonomous system nor destination. This autonomous system in the middle is just used to transit, pass through to reach the destination. Now here we have 4 routers. Now if you want to reach from A to F, it is not possible unless you do any of these 3. One is connect a physical cable from B to E. Otherwise, redistribute BGP into OSPF and OSPF into BGP, so that BGP routes will be learned by B router and it will send to D router and it will also send to E router. For the reverse path, you do again from BGP to OSPF and OSPF to BGP on the E router. Then the ping is possible. You can talk from A to F, but the problem in redistribution is it will take a lot of processor. BGP is a protocol which has huge metric and OSPF has just a cost. Now when you translate from the huge metric protocol BGP into OSPF, it loses all the quality. A lot of processor is needed again. It loses all the attributes. Right, so this is again not a recommended way. Translating into IGP like OSPF or EIGRP or REAP, it is not recommended way. Instead, we need to run BGP on all the routers, like C and D also run BGP. So the purpose of C and D is so that packet can move, BGP packets can move. But inside an autonomous system, they are going to move based on the IGP protocol OSPF, but still router should know the path to reach the destination. You need to run BGP on C and D also, and this is one. Next is IGP in a non-transit autonomous system. Now IBGP in a non-transit autonomous system, meaning how IBGP behaves when it learns the route from eBGP. See, router B and A are eBGPs because they belong to different autonomous system, and here it is partially meshed. Your transit area is partially meshed here, meaning there is no physical connection between B and E, and there is no neighbor relationship between B and E, but you have neighbor relationship with B and D, and you have neighbor relationship with B and C, but there is no neighbor relationship between B and E. So there is no BGP update is sent to to E from B. There is no update is sent from B to E. You may say D will send to E. No, whatever routes that is learned via an IBGP, meaning for D, B is IBGP. For D and for C, router B is IBGP. Same autonomous system, interior border gateway protocol. Rule is this: by default, route learned via an IBGP or never propagated to another IBGP, meaning whatever D learns from B, it will not say to E. Never propagated to another IGP. So how you will solve this problem? But I want to reach from A to F. If D is not going to give to E, how can I reach? How can F reach? How can A reach F? So the solution is you need to have a fully meshed, meaning you need to have a BGP neighbor relationship with E also from B. B should have neighbor with D, C as well as E. Only then updates will be sent. Otherwise, because of this rule, by default, routes learned via an IBGP are never propagated to other IBGP peers. Because of this reason, A cannot reach F. Solution is fully meshed IBGP. When I say fully meshed, I am not saying physical connection between B and E. We need to say in B, E is my neighbor statically. Again, I am saying we have not gone to the configuration level. In BGP, every neighbor has to be statically configured. You might have seen in OSPF non-broadcast network type, NBMA, we always say what? Neighbor. Likewise, here in BGP, everywhere IBGP or eBGP, unless you say who your neighbor is, they cannot form neighbor. More secured, because it's an internet protocol. So if you want to reach from A to F, then it should be fully meshed, means neighbor statement has to be given. Now, what if I don't have BGP on D and C? What if I don't have BGP on D and C? I have only B and E as neighbors. No, D and C is neighbor to B and E. D and C is not neighbor to B and E. Now also what will happen? A cannot reach F. There's a black hole. What will happen? Packet comes here to E, and since there is no route to reach the network on A, packet will get dropped down C and D. Right? So these are all the constraints that we have in BGP. Hope you understood the BGP foundation. The next video is part 2 of BGP, where we will be learning about the configuration part. So what we have seen so far, we have seen BGP is a internet protocol. It's an autonomous system by autonomous system protocol, path vector protocol, and the administrative distance for eBGP is 20. Administrative distance for IBGP is 200. Administrative distance for eBGP is 20. Administrative distance for IBGP is 200. And BGP supports multi-homing, where we can connect more than one ISP to our enterprises. And then we discussed about what is autonomous system, what is IGP, BGP, why BGP is an autonomous system, path vector protocol. The port number of BGP is TCP 179. It works on top of TCP 179. It sends periodic update. We discussed about different tables that we have in BGP, different type of message types that we have, and then what is BGP peer, what is IBGP, and what is eBGP. In IBGP, neighbors need not to be directly connected. eBGP neighbors need to be directly connected. How BGP behaves in a transit and non-transit area, and all these things we discussed. We will see the configuration part in the following video. Thanks for watching this video. See you in the next video. Bye bye.